Okay, good morning, good afternoon, and good evening. My name is Victor, and I'm going to be your anchor for this training. So this is the Cisco ITN, Introduction to Networking. This is a level 1 CCNA course. We've looked at the very first module about networking today. We've looked at how to basics of configuration of most of these end devices in module 2. So module 2, we're going to progress by looking at protocols and models. If you're not subscribed to the channel, please do so. And you could share these learnings with others. If you are any of our training students, either our physical students or our remote students, you could inbox, you could chat up and get access to the Cisco Network Academy. The Cisco Network Academy gives you opportunity to have a more elaborate content. These slides are a summary of all of the content you have in the Cisco LMS, Learning Management System. And this LMS gives you opportunity to take quiz, to take an exam, and also to be able to get a badge, a digital badge, a credit badge that you can have on your LinkedIn profile and the rest to show that you've gathered this knowledge, you've gone through the labs, and you're competent enough. Okay, so we're going to get to module 3 right away. Protocols and models. Okay, this is just some housekeeping. So the course starts from here. What are our objectives? The rules, protocols, protocol suites. I'm going to increase this a bit from current slide. Okay, so we want to look at rules in terms of communication. When you hear the word protocol, what are you trying to say? You try to look at how do I communicate? In the military, in different organizations, you have some people that you call protocol officers, protocol guys. So what they do is how people navigate from in and out, how people get through the door, screen people and say, okay, please, you cannot have access to this place is reserved, and the rest. So when you hear that word protocol, think about access, think about rules, think about how to moderate access to information. So the module objective is to explain how network protocols enable devices to access local and remote network resources. And this resource can be anything. It can be internet, it can be files, it can be hardware, it can be software, it can be anything. You could have a hard disk you have on your network, you want to be able to share. It can be a web server you have and you want to be able to have access to. It can be an email server. It can be whatever. Now, protocols. First of all, rules. Describe the type of rules that are necessary to successfully communicate. You have several types of rules. You also have several types of protocols. You have some protocol suites for different kind of hardware, different kinds of communication. We'll look at that in details later on. Then you have standard organizations. Who are those guys responsible for telling us, oh, if you are to manufacture any device, if you are to manufacture any hardware, make sure you conform to social standards so that every other device, no matter the manufacturer, can also communicate with your device. So they are standard, and we'll look at those organizations that are responsible for that. Then we'll look at some reference models. So the OISI is a little bit older. Then you have the TCP/IP, the Transport Control Protocol, and also the Internet Protocol. Then Open System Interconnect model. Those are stuff that helps to facilitate communication. Then we'll look at data encapsulation. We'll also look at data encapsulation, encapsulation, and de-encapsulation. So encapsulate. If I want to give you let's say bread, I can't just right from the oven, right from the pot or whatever, I just serve you the bread like that. I have to put it in maybe in a nylon, if it's a gift, I'll put it in a carton, I'll wrap it, I'll put it in a gift bag, and I will send it to you. So I have to encapsulate that data. I have to cover up the data, having several layers of information. Then, of course, when you receive it, you're going to now start unwrapping. So that's what you call it, the encapsulation. So you have to now start opening and opening and opening till you get to the actual data. So we're going to see how information, how data moves across our network. So this explains how data encapsulation allows data to be transported across the network. Data access a special host, access local resources on the network. We look at all of this. So these are our objectives for the training. Design communication system. So this is an activity. The objective is to explain the role of protocols and standard organization in facilitating interoperability in network communications. So when you hear the word interoperability, if you have a Cisco device and you have a Netgear device and you have a Dell device and you have a HP device, all of these manufacturers, they produce switches and routers. Yes, Huawei device, ZTE devices, they all make devices. How do we make sure they can interoperate? They can communicate together. Of course, that is about standards. So without standards, without protocols, irrespective of who the manufacturer is, you have to conform to protocols. Then what are rules? There's a video in your LMS that explains that. So networks can vary in size and complexity. I'll talk about rules later on. It's not enough to have a connection. Devices must agree. So rules are how do we decide to communicate? A husband and a wife, a girl and a boy, a boss and an employee. There must be some set standards. So those rules govern the communication, how you're going to have it, when you're going to have it, how you're going to throttle data between person A to person B and the rest. So there are three elements of any communication. You're going to have the sender, the receiver, and the channel through which that information is going to go from point A to point B. Just like when we looked at module 2, where we said, for you to have communication, you must have end devices, intermediary devices, and connecting medium or media. So all communications are governed by a protocol. You see this person here, you see this person here, message source, transmitter, transmission medium, receiver, message destination. So protocols are the rules that communications will follow. So without rules, then we can't communicate. So several rules, several protocols are going to be governed by several rules. And individuals must establish rules and agreements. If you have a husband and wife, like I talked about earlier on, you have a boss and employee, there's some set standards. There are some rules that govern how you guys communicate. So protocols must account for the following: identified sender and receiver, common language and grammar. You can't just come to me and start speaking your dialect or your language or your lingua franca. We have to have a common means of communication. Without that, it's going to be very hard for us to communicate because we don't have a common language. We're also going to decide the speed and the timing of delivery. Yes, we're going to decide and say, okay, please, you can't speak to me when we have a meeting in the office. You're going to speak to me when you have something in regards to so and so. If it's something else, please speak to somebody else, not me. So that's timing, speed, how regular, how frequent. How are we going to be confirming? How are we going to be acknowledging that you have sent something? For instance, if you want to browse over your browser, if you put www.google.com, something somewhere have to acknowledge that, confirm it, and send back something to you. So we're going to learn about the two-way handshake, three-way handshake, and kind of handshakes that don't need confirmation. So network protocol requirements. So there is need for encoding. So encoding has to do with you putting some information to help the other guy recognize what you have sent. If I send you an email, for instance, there must be some encoding that tells where it's coming from, for instance, where it's going to, for instance, what protocol are we using? TLS, are we using? What kind of encryption are we using? What encryption algorithm are we using? And all of the other information. So we must encode. Then message format and encapsulation, of course, the size, the timing, and the delivery option. So these are some of the requirements that you need for communication. So encoding is the process of converting information into another acceptable form for transmission. Decoding reverses the process to interpret the information. So you have to put in some information to enable this guy to receive it. So and of course, if you encode and this guy cannot pick it up, then you don't have communication. So message formatting and encapsulation, like I explained earlier on. Dear Jane, I just returned from my trip. I thought you might like to see my pictures, John. So sender, receiver, right? You put it to the mailbox. The medium is going to be the post office. There's a sender, there's a receiver, right? So, and the message format is going to depend on the type of message and the channel that is used to deliver the message. Okay, so message size, so very important. So it then means that if I cannot take up the size that you're sending to me, definitely I'll not be able to get that information. Yes. For instance, you're sending a terabyte data to a 100 gig hard disk. Can you pick it up? No, no way. So encoding between hosts must be in appropriate format for the medium. Or for instance, you are sending data over a 100 MB per second Wi-Fi device or Wi-Fi adapter. But the guy, or that the device is a 100 MB per second device or router or radio, but you're sending stuffs in terabytes. Of course, that's not going to happen. So timing also, and that's what we call flow control. So flow control has something to do with quality of service, right? So this manages the rate of data transmission and defines how much information can be sent and the speed at which can be delivered, like I said earlier on. So if it's difficult for me to accept at the rate which you are sending that information, of course, there's nothing I can do. Then, of course, response timeouts. For instance, if you say www.google.com, if your internet is not active, it rolls and rolls and rolls and rolls, takes some time before it gives you that timeout message. So later on, we're going to be looking at some of the flags. You have the reset flag, you have the urgent flag, the push flag, the finish flag, the urgent flag. There are about 6, 7 of them. So all of these are different flags. For instance, you send a message, it can be urgent, it might not be urgent. There must be a synchronized flag. Then if the other guy does not see it, you might have a reset flag. So when that reset flag goes out, it does that at times 2, 3 times, depending on what the protocol is. Before, if it's not available, it sends back a message and tells you, Google, unavailable. So behind the scenes, something is happening, communication is going on. So message timeout or response timeout manages how long does the device wait when it does not hear a reply from the destination before it tells you, oh, please, timeout. Access method. So determines when someone can send a message. This may vary depending on the rules. So there are several delivery options. So there's what we call the unicast, the multicast, and the broadcast. So you say unicast when it's one-to-one communication, just I and you. Multicast, one-to-many, typically not everybody. Then broadcast when it's to everybody. So about node icon. So this is just a representation of what we spoke earlier on. So just this guy to this guy to three guys, but not everybody, then this guy to everything. So that's what you call a broadcast. Protocol. So like I said earlier on, network protocols define a common set of rules. If you're making hardware, if you're making software, no matter who you are, you must conform to protocols because that will help interoperability. If you don't conform to protocols, then other people's device will not be able to communicate with your device. Protocols are going to have their own function, what they do, their format, how it's being sent, the rules, what governs how information is being sent. So, okay, I think I have a note here. Let me explain this to you. Protocol type, then of course, description. So you have some protocols that are about network communications. You have some protocols that are about security. For instance, network communication, where you're talking about stuffs like HTTP, right? Stuffs like ICMP. These are protocols. Network security. Oh, how do you ensure encryption? So that's where TLS is. SSL comes in. HTTPS comes in. What is it called again? SFTP. All of the protocols that helps you to secure data. And of course, routing. So there are several protocols that talk about path, like in CCNA 3, where we talk about OSPF, we talk about the border protocol. How do you communicate from one router to the next router? All of that are just routing protocols. Then you have the service discovery protocol. For instance, when you ping, when you do things like traceroute, traceroute, when you do stuffs like what again? Use for automatic detection of services, devices or service, or when you say ARP, address resolution protocol, if you say ARP on your command line, and several other protocols, so they all serve different types of functions. Then some functions can be for addressing, it can be for reliability, it can be for flow control, it can be for sequencing. Sequencing, we mean I might not be able to send all of the data I need to send all at once. I might need to segment it. I might need to sequence it. I might need to break it into small pieces. I might need to send them in piecemeal. So if I need to do that, so I will need somebody to be able to tell me, okay, this is batch 1, this is batch 2, this is batch 3. I'm just put them and they all go in a piecemeal. The sequencing uniquely labels each transmitted segment of data. If you have 1,000 persons get into a stadium, they can't just all get into the stadium. Remember, we're talking about protocols. We're talking about rules of engagement. We're talking about rules of communication. So how do we ensure transmission of data from point A to point B? From everybody's home can be point A. The stadium can be point B. What's going to be access medium? The stadium gates. So a protocol is going to help us sequence all of the guys getting to the stadium. So at the gate entrance, we might need to segment those guys and say, please come in tens, 10, 10, 10, 10, 10. Each of those tens are segments. So you have some protocols. Example, like I made mention of HTTP, that's Hypertext Transfer Protocol. That guy is responsible for anything web. So if you are doing cybersecurity, for instance, and you see that protocol, that means, yes, if that port is open, then there is something that has to do with the internet. Maybe a browser is on, or a particular application is communicating to the internet. Anytime you see the guy TCP, that's the transmission control protocol. Anytime you see the guy IP, that's the internet protocol. Anytime you see the guy Ethernet, so that's the guy that manages all of my NIC, my LAN, my WAN, and the rest. Or rather, okay, yes, that's fine. So protocol suites, at times they come in suites. So when you have a group of interrelated protocols necessary to perform a communication function, you call them a protocol suite. So I think, okay, let me just show you. So this is what it looks like. So there's a suite. So you have the OSI model. I normally say, please do not take sweet potatoes alone. Please do not take sweet potatoes alone. I'm trying to. Oh, shut just a second. Let me end the slideshow. Okay, let me go back a bit here. Okay, I think let me write it here. Where should I write it? I think I have space in the next slide. Okay, let me write it here. Please. Okay, let me write from down. Please do not take sweet potatoes alone. I love sweet potatoes. Did I take sweet potatoes today? Maybe. But I have some. Alone, let me make this, take away the bold. Supposed to be bold. Okay, whatever way. So I say this is physical data link layer. So this is network layer. This is a transport layer. This is a session layer. This is a presentation layer. This is the very last application layer. So you normally do your stuff from down up. So this is the physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. Look at it this way. If you want to send data to me, right, it first leaves your physical layer, your hardware, right? It goes out from your Ethernet port to your switch, gets into your switch, gets into your router, this layer 3, goes out of your router, gets into your station, your software now, depending on whatever you're using, gets into presentation, depending on how you're delivering that. Then, of course, I'm going to be able to view that from application. If I want to reply that email or send you back that information, I'm going to go from, let's say, my browser. It can be Chrome, it can be whatever. I'll send that. It goes through presentation, session, transport, my router, my switch, and gets back to my hardware into my system. So this is, let's call this an acronym. Please do not take sweet potatoes alone. So that's one way you can memorize the TCP/IP protocol. So these are the layer names. So network access, all of the guy from data link layer down into the physical layer, you call that the network layer. Then the internet layer is what you refer to as the transport layer. That is this guy, the network, and yes, just the network layer. And the transport, it's called this. Then everything here is called the application. So this is a more detailed explanation. So you see the network layer, the internet layer, transport layer, then the application layer. So look at it as, how do I communicate? And for my different layers of communication, what are the different protocols that are responsible for communication? So you see this application layer, that's where you have softwares most times, right? So you can be having servers, domain name systems, or domain name server. If you buy a host or you are running Active Directory, you need to configure DNS, a domain name server. If you are going to be doing some configuration, if you need to use a DHCP server to assign IP address to your systems, if you need to use email, if you need to transfer files either through FTP or that's file transfer protocol or secure file transfer protocol or TFTP, that is trivial file transfer protocol. That's all in the application layer. Same thing with the HTTP, HTTPS, and REST. Then at this layer, you talk about the connection-oriented communication and the connectionless communication. If I have time or see it within the curriculum, I'll explain the difference between these two guys and their different applications. There are differences, there are advantages. I won't say there are disadvantages, right? They are just two guys meant for different purposes. For instance, you say TCP connections, things like HTTP for web access and the rest, they need end-to-end connection and confirmation of an acknowledgement of data transmitted. Things like video conferencing, things like voice over IP, they utilize UDP connection type of protocol. Same for the internet layer. This is where you have your routers, and this is where you have most of the times your switches, your network access layer. So this is where you have IP address, IP version 4, IP version 6, then your NAT, your network address translation. That's the guy that's responsible for translating your local IP address to your public IP address. Okay. Let's say you have my IP address. So this is my IP address, 197.2.10.5265. Yes, you could Google this, you could put this on Whois and get to know where I'm operating from. No big deal. But you see my local IP address, 192. So if you compare this and this, sorry. Yes, this guy, 192.168.1 is my, in our previous model, we saw that is our server here. Then 102 is my IP address. See, there's no relationship between this and this. So NAT, network address translation, is the guy that translates this, my IP address I use within my local network to communicate within the devices here, and the IP address that my ISP has given to me. So NAT does that. DHCP does giving me 102 from this guy. So this is my gateway. So DHCP has helped me to assign an IP address, as an assigned IP address to every other person. Whereas NAT helps translate this to this, so that if I'm getting information back from somebody, I'm trying to read an email, I'm trying to access something on the internet, it goes into this guy, I cannot have it. So, and many more other protocols in the suite. So something you want to study. So communication process, so it goes from the data layer to the TCP segment, then to the IP where you have the router, to your Ethernet. Same thing applies for maybe a web client, a browser to the web server. So that's what you refer to as encapsulation and de-encapsulation. Here you take up, you wrap the information. Here you unravel, you open up the information. Standard organization. So there are several organizations, the IEEE, the INA, the ICANN, the ITO, the TIA, the ITF, the task force guys. So they are the ones that encourage interoperability, competition, innovation, vendor neutrality, and they help to make sure that whatever the vendor, theirs is just to establish standard. So you have ISOC, you have IAB, you have the IETF, and you have the IRTF. If you want to buy a domain name, for instance, the IANA is responsible. You have several other standards for different geographical locations, like in Europe, like in America, North America, South America, Asia, and Africa. So that's the guys, the responsible for assigning IP address, domain names. So when you buy that domain name, right, they're responsible for assigning name standards. So a small fee goes to them. It goes to your vendor like that. So I think there's a research work here in your lab. So that should be lab. Let me see. That should be lab. That should be lab. Research networking standards. That's lab 344. So please, if you're student, you should have this material. What is it about? It's about research networking standards organizations, reflect on internet and computer networking experiences. So it just more or less is research. So who is Jonathan B. and posted and what is it known for? So this is just a case study. Wow, you have quite some standards here. You need to research, learn about them, know what they do, how they do it, and how they help the internet move forward. Okay, so what organization oversees IAB? So ISOC oversees IAB. So you need to learn about some of these standards. They will help you understanding how the internet works. Current slide, yeah. So reference model, so yes, so you could use the OSI model. Please do not take sweet potatoes alone. Or you could use the TCP/IP or the protocol suite or the TCP/IP model. So whichever. If you're to do cybersecurity, this is also very, very important. Or if you have to move move to the second level of CCNA, very, very important. You want to understand the standards. I might upload something separate to give more elaboration on just the OSI model. So it's a very important concept you want to understand. It's going to understand it's going to help you understand networking properly. It's going to help you understand cybersecurity. It's going to help you understand communication. So something you want to read up more about. Yes, I've talked about this earlier on. Foster competition, prevent technology or capability changes in one layer from affecting other layers above or below. So whatever vendor you are, you conform to the standard. It's a common knowledge, right? To describe networking functions and capabilities. So no matter who is producing that device, they make sure they utilize that OSI model in making their devices. So this is an explanation of the different layers I talked about. The physical layer maintains active, maintain, and deactivate physical connections. So those cables, your cards, right? Your data link layer, so this is where your switch is. Your switch operates at layer 2. Your router operates at layer 3, because that's where you have your network, your router. Your transport layer, segment transfers, your session layer, then your presentation layer, of course, and your application layer. So you should be able to understand the different protocols that operate at different layers. So this is it here. Are you there? These two guys here. 3, this guy. It's only a switch. For instance, a MAC address is layer 2 because that's where you have your switch. IP address is layer 3 because that's where you have your router. So don't mix it up. So you want to understand this and understand which protocol operates at what layer. Okay. That's something. So there's a lab here. There's a packet tracer lab. We'll do everything that has to do with packet tracer later on in the course. So for now, we just want to lay all of the foundation. So in Packet Tracer, you could examine HTTP web traffic and display elements of the TCP/IP protocol. Even later on in this course, we're going to be using a tool called Wireshark, right? It will help us understand most of these things. Data encapsulation, I've talked about that. Segmenting messages, you want to break up things, right, into smaller units. So multiplexing is the process of taking multiple streams of segmented data and interleaving them together. So you don't just want to take all of your message and send it to your destination. Like the example I gave you about 1,000 persons from their homes getting to a stadium that just have a gate that can allow only 10 persons at a time. So segmenting is you breaking that up. Okay, so sequencing, you see it? You have to say who goes first. So it's a process of numbering the segments. So the segment is what you've broken down. Sequencing is saying who goes first, so that the message may be reassembled at the destination. If you break up everything, of course, everybody's going to now become just one set of hand, right? If I'm to use the stadium example, it's just like you have 10 pieces of, let's say you want to ship a vehicle from Europe to America. So it's somehow cheaper to ship them in piecemeal. The brakes, the tires, the rooftop, the front section, the back, the bodywork, just the doors, just take everything down into piecemeal. That's segmented. So sequencing is you giving them numbering so that at the end of the day, when they get to their destination, you can now reassemble the car. Okay, do you have anything to explain here? Nothing much. Anything to explain here? Nothing much. I've already talked about encapsulation and de-encapsulation. Yes. So data access. Both the data link and the network layers use addressing to deliver data from source to destination, right? So whether it's the physical, the data, the network, the transport. So here we're saying, how do we address? So for physical, timing and synchronization bits. For data link, destination and source physical address. So when you hear physical address in networking, you're talking about the NIC card. You're talking about the MAC address. That's what we call the physical address because it comes from the manufacturer. It's hard coded to the device. Let me see if I can see the MAC address. Okay, I can't see that. Let me clear my screen. Or clear screen. Okay. I think I can increase this guy. Looking kind of small. Still small. Okay, sorry. Font size. Let me make this bigger. Good. Wow. So I was talking about what? I was talking about, yes. So I will need to say ipconfig/all to see my MAC address. Okay, good. Because if I say ipconfig like I did earlier on, I'm just going to see the IP version 6 address, IP version 4 address, and maybe the subnet max. But if I say ipconfig all, wow, I just have so many adapters on this system. So it's going to be showing me the media states. I think this time around, in the previous module, I was using a LAN cable. This time around, I'm using a Wi-Fi. I'm using Wi-Fi. So let me look for that adapter. Okay, this is it here. So you see, this is my Wi-Fi. This is my physical address. So this is the MAC address. So you call a physical address the MAC address. DHCP, dynamic host configuration protocol enabled, yes. So this is my IP version 5 address, sorry, 6 address. This is my IP 4 address. Yes. You see, my IP address is different from my previous IP address because the ISP I was using to record module 2 is different from the ISP I'm using to record what's it called? This module 3. So this is layer 3, layer 2. Yes, please get that. So this is your MAC address. So that's this guy here. So it's on data link layer, destination and source physical address. So this has to do with the MAC address. Then network, destination and source logical network address. So when you hear logical address, you're talking about the IP version 4 and the IP version 6 addresses, right? Get that. So transport. So here you talk about ports, right? Destination and source process network process numbers or ports. So the question is, at what ports am I communicating? I won't be able to get that information from my CMD. I might need to use TCP. Do I have that on this system? Okay, let me see if I can see sys internals. Okay, good. I think I have sys internals. So sys internals is a Microsoft suite. It has several applications. TCP view is one of it. I love it. It could show me whatever that is happening on this system. It could show me my source port. It could show me my destination port, right? So this is what it looks like, right? So it's saying my process name, process ID, protocol. So this is my protocol, right? I'm using TCP. This is the ports, and this is the remote ports. This is local port, destination port. You see, I'm on Zoom. This is the local port. I'm using 443. 443 is HTTPS, so it's kind of a secured connection, right? So the source, the destination. Remember, we're talking about communication. We're talking about internet protocol. If you want to download sysinternal and have access to most of these tools here, you can just go to download sysinternals. This was done by a former Microsoft employee. It's available free. You could download it. You could use it. It has several nice tools. So just 45 MB. Once you download it, you have access to several tools, including this one I just opened now. So these are all the tools, quite a bunch of them. Process, autologon, something on tags, something on disk management, something on some protocols, something on process view, something on shell, something on TCP view, and the rest. I love the TCP view very well. I hope you love this. You could see all the things that is happening. For instance, if you're doing digital forensics, you could use this to see background and hidden stuff, right? So you can see this is my current active connection. Okay, let me write on. Then you have upper layer where you have encoded application data. So this one is going to happen at the particular application. Like I'm on Zoom now, so this is going to happen within the application Zoom. So this is your application layer. So you see, I've just tried to explain the OSI model in practical terms. The physical layer, that's where you have your LAN, your cables, the adapter itself. Here, that's where you have your switches. That's where you have your MAC address. Here, that's where you have your IP addresses, your router. This is where you have ports. I've explained that. And this is where you have the actual application. Okay, is there much more? Okay, I've talked about source IP address, destination IP address. You see it? This guy coming from here, going here through two routers. So in Cisco, anytime you see this guy, this is a router. R1, router 1, or router 2. Just like we have here, IP address local. So this is just my IP address. Same IP address, 192.168.184.119. Where is it? Sorry, just a moment. Hope I'm not confusing anybody. Yes, this is it. 192.168.184.119. That's the guy here. That's my IP address. This is destination remote. So the question that can we find out? Oh, wonderful. So we could run a who is here. That's what I just wanted to do. I wanted to copy this guy. What's happening? So we could run who is and see who owns 206.247.75.208. Okay, fail to get who is information. Let me copy that. Go to whois.com and drop. Oh shit. What's happening? 206. Okay, 206. 206. Okay, 206. 206.247 dot 7528 75.28. So we could just do some little get out here. So just 75. Oh, stop sharing, share again, share everything. 75.208, yes. Yeah, Zoom. I hope you can see this. Just a moment, share screen, yes. So you see, this is Zoom communication. So it just tells me that this IP address is owned by Zoom. So this just confirms my communication from my PC to this guy, and is on port 443. Port 443 is HTTPS, or secured communication, web communication. Okay, let's get back. So you see, it's source IP address, destination address. Same thing for IP version 6, same thing applies. Same thing here, the same thing I've explained. Same thing, it can be remote network also, same thing. Same thing, just explain that. Different IP network, same thing. They mustn't be on the same network. Same thing, just all the things I've just explained now. Okay, what else? It's new here. The MAC addressing for the second hop is source, first router, exit router. Yes, this just tells you how the data moves from point A, gets into this particular guy. The NIC, that's the network interface card, gives information to this guy, then before it gets to the server. Okay, what else again? Makes sense, different from what I've explained. Yes, please install Wireshark. This is lab 379. Install Wireshark. So don't forget, we're going to be running this lab separately. We'll see how much we can run. There are about 25 labs in this course. So download and install Wireshark. Is a packet tracer, is a packet sniffer. So to sniff, to steal, to investigate. So we're going to be using it in this course. The required resource is just your PC and internet access. Just go to wireshark.org, download, install the nice version, agree to all the terms and conditions, and you're done. So in lab 3710, that's where we're going to now start using Wireshark to view information and try to do some investigation of our ICMP data, right? We'll do that separately. So this is what it looks like. See, these are the labs. Very, very nice. Okay, But for now, we're just trying to lay foundation. So this is lab. So that's all for module 3. So after the entire course, we're going to do separate recording for each and every one of the labs. So we're going to go through the labs one after the other. Thank you very much for taking part in this module 3. It's a long slide, 73 slides. We're able to do that in record time. If you've not liked, if you've not subscribed, please do that and do share. See you in module 4.